So this video is just a quick introduction into MRAM, LRAM, and RRAM. And what these are MRAM is middle rectangular approximation method, LRAM is left rectangular approximation method, and then right rectangular approximation method. So those are the words, but what do they actually mean? What they do is they help us approximate areas under a curve. So let's say you've got a graph like this. This is the x and the y axis. The graph looks something like this, and maybe there's something meaningful about the area under the curve here. Like for instance, if this is a graph of miles per hour, if you were to find the area under the curve, then you'd find the total miles traveled by this vehicle or person or whatever. Probably a vehicle if it's miles per hour, but I guess a person running maybe it would be miles per hour. So the area under the curve can tell you something. Okay, so how do we find this area since it's such a weird shape? It doesn't make a semicircle perfectly, it slopes off to the side. Well, we have a calculus technique that you're eventually going to learn, but what computers usually do is, as far as I've come to understand, is that they use these approximation methods to find the area under the curve instead of a calculus solution. Okay, so that's here. The basic idea is what you're doing for MRAM is that you're splitting this area into some sort of subinterval of equal length. So maybe it's an interval where it's 2 across on the x-axis like this one's going to be. So here's x equals 2, here's x equals 4, x equals 6. We're splitting it into easier to digest chunks. And then you find the middle for middle rectangular approximation method. You find out the middle y value. So at x equals 1, this is approximately the y value. And then you calculate the area of that rectangle. So when you do that, look, you got a little extra space, so this area is going to be incorrect. It's not the exact area under the curve. It's overestimating a little bit, right? But in the next one, we look at x equals 3 because that's somewhere in the middle for the middle rectangular approximation method, and there's where we would draw a rectangle. And for x equals 5, the rectangle would be somewhere up here. All these are over approximating just a little bit, but it's going to kind of balance out because on the other side of this curve at x equals 7, there's our middle. Actually, so it's under approximating a little bit too. I missed that. So it's already balancing itself out. This is an over approximation, but this is also, we're also missing this area too. So you can see how the rectangular approximation method, it's missing some key details, but if you take really small subintervals, which is what a computer does, then it gets really, really accurate about finding that area under the curve. Okay, but that's what those rectangular approximation methods are. So I just did MRAM. So same intervals, x equals 0 to x equals 2, x equals 2 to x equals 4. If we do LRAM, then you just use the left side of your interval to dictate the height of those rectangles. So at x equals 0, that's the starting point of this interval. This is the height of the rectangle. So LRAM is drastically under predicting the area of the curve here. And so for the interval between 2 and 4, this is the left side of that interval, so that's the height of our rectangle using LRAM. From 4 to 6, this is the left side of our rectangle, so LRAM is again under approximating. From 6 to 8, LRAM is starting to over approximate a little bit maybe, a little miss there. From 8 to 10, use the left side of the interval and you go to wherever the left side of the interval hits your graph. So now LRAM is over approximating on this side, right? It's picking up area that we don't want. So it kind of balances itself out there. And you might be wondering, why are we using rectangles? Why don't we use other shapes? You certainly can. There's the trapezoidal method. There's probably other methods that I don't know about. But this is just the basics about approximating the area under the curve. So that's LRAM. You can probably guess what RRAM is going to be. You're still looking at your subintervals. From 0 to 2, that's an interval. 2 to 4, that's an interval. So LRAM is looking at the right side of the interval to dictate the height of the rectangle. So this is at x equals 2, the right side of the interval. So that's the point on the graph, so that dictates the height. So from 2 to 4, if you follow x equals 4 up, that's the height of the interval. From 4 to 6, that's the height of the interval. And then 6 to 8, if you at the right side of our interval is x equals 8. So if we follow that up, this is where it hits the graph. Now it's starting to under approximate, right? That's RRAM. Okay, and we'll demonstrate all three of these with data. You could see how you could probably do it with a function. You just got to plug in x equals 2, find out what the y value is. Plug in x equals 4, find out what the y value is. So for this particular problem, we're asked to, what do they say? Estimate the area under the dye concentration curve. So you can plot these data points. Look, this is seconds. That's a time interval, a time unit. And so time is usually on the x-axis. That's just our tradition. That's the independent variable. It's not influenced by something else. Unless you want to get into like physics and gravity in that movie Interstellar with Matthew McConaughey, I don't know, McConaughey or whatever. He's so dreamy. Okay, so x equals 2, 4, 6, 8. I've got them all listed on the x-axis. And then these will be my y values. So 1, 2, 3, 4. That's probably good. So you probably want to just get an idea of what this curve looks like. Plot the data points. At x equals 2, we got a y value of 1. So I'm going to put a dot right here. At x equals 4, I've got a y value of 1.5. At x equals 6, I've got a y value of 1.9. So that's a little bit closer to 2. At x equals 8, I've got a y value of 2.9. Bit of a jump there. X equals 10, y value 3.9, x equals 12, a little bit higher. Okay, so we got the data points. Let's start with LRAM. I'll come back to MRAM for this one. Let's approximate the area under the curve using LRAM. So there's natural subintervals here. If there aren't, you'll have to define your subintervals. You could say I'm using a subinterval of length 1, which means x equals 1 to x equals 2, I've got a rectangle. X equals 2 to x equals 3, I've got a rectangle. So with LRAM, this is our interval, and we use the left side of the function to help us define the rectangle. So I'm using this data point, and that's my rectangle that I need to calculate the area of. And that's real quick, right? The area of a rectangle is length times width. So it's 2 across, and then it's 1 unit up on the y-axis. So 2 times 1 makes 2 for an area. And then we go on to the next rectangle. From 4 to 6 is our next subinterval. I'm using LRAM, so I'm going to use the left side of the function to dictate the height. So again, it's 2 across. And now the height this time is 1.5. That's the y-coordinate. So it's 1.5 going up this way. So 2 times 1.5 gives us 3. X equals 6 to x equals 8. We use the left side of the interval again to make our rectangle. The left side, this data point right here is a little bit below 2. That's our y value of 1.9. So 2 times 1.9 gives us 3.8. And then you can see how you can keep going. You keep going, add up all those rectangle areas, and then you've got your approximation for the area under the curve. And notice I'm not even using this data point at all for the left rectangular approximation method. Okay. Then I'll show you real quick how I do this with a right rectangular approximation method, and we'll talk why MRAM doesn't work in this example. So right rectangular approximation method, you look at your subintervals, but you use the right data point to dictate the height. So using right rectangular approximation method, it's 2 across, it's 1.5 up, because this has a data y value of 1.5. So that's 3 for a height. Same thing with this one, I'm using the right side of my interval, so that's 3.8. And then this one, the right side of the interval. So it's 2 across, and it's 2.9 high. That's 5.8. Then we can keep going, right? So that's right rectangle. Look, if you try to do MRAM, what's the middle? We don't have a data point here. So with discrete data like this, you often can't do MRAM because you don't know what the middle point is. You could do MRAM if you used subintervals of length 4, right? Because this would be the middle point, and that would be the height. So 6 to 10 would be our next subinterval. We use the middle point, but we can't do it if we're using subintervals of 2.